DefSAT 2025 features for the first time ever the exclusive technical sessions showcasing disruptive technologies from companies like Safran, Planet, C2C Advanced Systems, and Anand Technologies. These sessions will provide invaluable insights for startups, fostering collaboration between emerging innovators and established industry leaders to advance space technology and strengthen India's defense sector. So, for the first tech brief on space situational awareness, may I call upon Mr. Noel Ballard. He's the EVP Sales and Marketing, Safran, here on the dais.
Slide will appear.
Okay, here?
No.
No, this one.
This
Okay. Okay. Thank you to SIA-INDIA to give me this opportunity to present capabilities of Safran and mainly Safran Space, as you will see. I have the honor to represent Safran Space today, and I will have a quick touch also on Safran AI, because you will understand through this technical presentation the need for also artificial intelligence. We have a global presence worldwide. We are deeply involved in India since many years, and we have several operations spread out of India, but also into India, in Mumbai, in Hyderabad, Bangalore, Trivandrum, and Chennai. So again, we are heavily supporting the Indian industry. We are working with integrators, directly with space agencies and International Ministry of Defense, and also very close with the new space companies, whatever they are in India or in US or in other countries around the world. What does Safran Space do? We are involved into electrical satellite thrusters. We do onboard satellite and ground optics. We do command control satellites and high-speed modem for collecting data from Earth observation satellites or mission probes. We do timing and radio navigations. I mean, this morning we were speaking quite a lot about PNT, position navigation timing, which is a big thing for us, with very accurate atomic clocks, which are used in your GPS, NAVIC, IRNSS, former name. We do also high accuracy inertial measurement units and inertial navigation systems. We are doing avionics for launch vehicles, whatever they are, what we call traditional launch vehicles, like the one you find in Europe, for example, in US, or also on new launch vehicles, what we call access to space, new space. And I will emphasize more on the space and spectrum awareness, which is part of a space situational awareness. Our technology is based on passive RF. You have different technologies and you need different technologies to have a complete space domain awareness capabilities. You have a space-based, I mean, you have heard of it, I'm sure, which can do typically very low Earth orbits type of satellites, which can look at upper orbits and be close to the objects to be detected. The limitations is the number of revisits, update of the data you can get. You have ground opticals, which can detect active and passive RF objects, and so can detect debris, what we cannot do with passive RF. You have some constraints about weather, day, night, this kind of thing. You have ground radar, which is efficient on debris and typically low Earth orbit satellites. It's costly. It's limited efficiency on MEO and GEO. And finally, you have a ground radio, which has no limitation regarding day, night, or weather. It's active 24/7, 365 days, but it's limited to RF active objects. We have been working since quite a long time into RF and satellites type of equipment, more than 30 years. Today we are tracking more than 800 satellites, whatever they are GEO, on which we focused on at the beginning, MEO or LEO. We have 7 years of data. You can imagine the amount of data it represents. We are down to 100 meters accuracy on GEO orbits, and we will be much better on LEO. We are much better already because we are at 1/3 of this, but we can get better. As I said, 24/7, 365 global coverage. And one important thing that you can not neglect is that we have 200 antennas, more than 200 antennas around the world to collect data from space. So what we do offer, data and information services. Speaking about WeTrack, which speak by its name, it's really tracking satellites based on the RF frequency that they are transmitting, whatever it's for the command control, it's on the payload, and with delivering persistent orbital positions. And one thing that our customers are tracking, commercial customers, definitely, and also government customers, is maneuver detection. As you can see on that slide, we are representing horizontally the world, with North America on the left side, Europe in the middle, and Asia on the right side. And we cover the different frequencies from typically L band up to K band. We have a basic functionalities, which is WeWatch, which is determination of orbital position. So we have a set of antennas which are measuring the time difference on arrival, frequency difference on arrival, with some advantage of frequency determination on arrival regarding changing positions to raise alarms. And by computation, we provide the ephemeris. You can see on the diagram below, you have all the GEO arc, for example, and you have satellites. You have co-orbited satellites in the same orbital slot, and it's easy from an RF determination point of view to isolate one satellite compared to the other, and provide the exact orbit determination of each satellite. So use case, early maneuver detection, as I was mentioning earlier. It helps also the optical observation if you have optical telescope associated to collect the data of space surveillance. You have to protect your assets, and it's very important that you check the assets and you check what is around or getting around your assets. We can provide also data for satellites, what we call satellites of interest. So some customers are asking for a number of satellites to monitor, and we provide this service. In-orbit servicing, continuous tracking on the payload or telemetry signals, as I mentioned earlier, and very accurate due to measurement error bias. And there's no cross-tagging, I was mentioning, which can happen with optical, for example, or if you don't have a clear visibility, which is linked also to optical. One thing which is important is we have customers which are recalibrating their ground stations dedicated to the ranging, so the control of the position of the satellites. So with constant tracking of the drifting satellites. Satellites characterization, we can select one satellite and give all the RF signature, whatever for the command control of a satellite and the different frequency used on transponders. So it's very exhaustive type of information. The behavior, generally speaking, because we are recording all available data, and we have a refresh rate of typically 10 minutes right now, and improving with the number of antennas that we can implement around the world. Flight dynamics, also it helps the satellite control people to refine their simulation for flight dynamics. It can be a backup for a ranging type of thing, and definitely help for calibration. Other use case that have been used recently, the X, what we call X geo tracking. So it's behind the geo arc. I mean, greater than 32,000 kilometers. And two examples were the Artemis Orion mission that we tracked until the orbiting on the moon, and data available on Chandrayaan-3, which was a great success for India, and we were proud to contribute to that success. Early orbit positioning tracking. So we provide that as a service. When some customer, typically there's more and more demand for that, because the electrical propulsion gets much longer time to move from leaving the launch vehicle up to its orbit. So it's important to have during that phase refresh rate of the position of the satellite, and LEO tracking, or what we call non-GSO satellites, generally speaking, where we have a commitment, we have a contract to be able to track more than 4,000 satellites by mid-2025. The LEO satellite service has started, in fact, 2 years ago, but it's becoming commercial available since the beginning of this year. As you can see, we have a global network of ground stations around the world. We have all the antennas that you can see here are belonging to us, and we are providing the service. we have some customers, I mean, government organizations who have their own network of our antennas and with software. So we provide also systems to be independent, typically for Ministry of Defense. And basically each set of station is a set of 3 stations, 1 RF characterization station, and 1 which is capable to be a backup in case of we have 1 station failure. And we are covering the entire world. So this is an example of what we can display. And oh, I think it's finished. Okay. So what I mean, it's not the latest presentation, and I apologize for that, because we have also capabilities of providing products and services for artificial intelligence, and especially related to intelligence mapping, where we are able to characterize all the objects, whatever their type, whatever it's tanks, for example, military vehicle, generally speaking, commercial vehicle, tent, fighters, helicopters, or people with guns, and map the people. It's a pity because I had a nice map of the airport of Delhi, where we had identified the commercial airplanes, military airplanes, around some public vehicles and some military vehicles. I mean, definitely I would like to invite you to visit our booth, where we can do demonstration of the different topics I spoke about right now. And I'm open to any question you may have.
Can you elaborate more on your AI products?
I mean, it's, I would have loved to, but the presentation has not been loaded. So the best thing is we have 2 specialists here. So if you have time to come to our booth, definitely we can show you some demonstration and explain what kind of capabilities we are offering. You're welcome. Any other question? So, thank you for your attendance, and wishing you productive 3 days. Thank you again.